Engrams and AI, Learning and Perception. The concept of AI being modeled after human brains goes even further. AI stores and communicates everything that it learns in a data container called an engram. Engrams are used in neurons. Engrams are the heart of information inside the neuron's nucleus. Engrams are chunks of knowledge, chunks of goals, chunks with associations and contexts. Engrams represent thought, and they move between the different subsystems of the AI brain. Both engrams and neurons are assigned unique IDs, unique identifiers that are numbers that are called tokens. Tokens are mathematically derived unique numbers that leverage what is called mangling and global unique identifiers, or GUIDs. The neuron nucleus contains data-efficient tokens that point to its associated engram. There are literally 200 billion neurons with the current technology in the world that swim around and throughout the AI brain. There are correspondingly engrams to support all of those billions of neurons that are blasting throughout the AI brain. As tech evolves, there will be even more neurons and more engrams powering artificial intelligence, making AI even more impressive and powerful, making it an incredible ally that will make our lives infinitely better, or may become a greater threat that may in fact ruin our lives or even ruin and destroy the world. Let's get deeper into engrams. Engrams are containers that contain one or more things. Things that are like single words, like people, places, cat, dog, car. Engrams contain context for and between data and instructions, and what is most likely and most probable to come next. Like, what might the most likely word be following another specific word? For example, if you saw the word white, it might be followed by wedding, and wedding might be followed by itself the word dress. Engrams contain data and instruction context, so the AI can calculate the most probable, appropriate, next related thing. Combining the full context of words yields for the AI something like white wedding dress as the most probable series of words. Of course, more data and more words will further refine the probabilities of what should come next. Or another example of this might be climate change dangers. Engrams contain things like media digital elements or components, like art and audio. They are also stored and have their associated contexts. Engrams contain things like goals and directives, mission requirements, things like don't harm or kill humans. Engrams are very important to making decisions. AI uses engrams to understand context of individual words or images, or of sound or music, pretty much everything. AI learns, AI creates, and uses engrams to predict the probable next engram as it relates to the prior engram that it's looking at or using. Imagine a person anticipates words as they listen or read based on the context of what they are reading or saw or heard previously. Imagine a person does this with the knowledge of things. And the people, well, they know things typically go together, they are associated, and how they are usually sequenced one after another. AI, like people, builds a knowledge bank, a vast, complex neural network database of billions of engrams, which it uses to understand and to predict and to communicate and to create even to innovate. Engrams are the building blocks to AI's deep learning and to AI's deep thought, to AI's actions and to its decisions. AI uses engrams to store, prioritize, and recall language, directives, goals, and media, and to recall everything in the world. AI uses language to organize its data and their relationships, just like how humans use language to organize their thoughts. AI uses engrams to store the smallest elements of any category of data, just like humans might do. Like language, images, music, and so forth, they're all broken down. In fact, AI breaks down even pictures, sentences, music, etc., all into their smallest individual components. And then it stores them all separately, but with their relationships with each other. AI uses engrams to understand the world and influence its decisions and its creations. AI uses engrams to communicate and interact through human language prompts. Well, that was a lot to digest. Here is a quick example of picture breakdown by an AI. Imagine the AI sees a cat in a picture. The AI compares the cat to its existing network knowledge. The AI recognizes the cat matches close enough to other images of cats. The AI assigns the human language word cat to the image of the new cat. The AI concludes the thing must be a cat. The AI generates and assigns a token, a unique identifier for the new cat. The AI creates an engram to contain the new thing, the new cat. The AI stores the details, the associations, the relationships about the new cat within its new engram. And now the AI can serve up the new cat to humans who may have need of it in the future. Okay, AI also breaks things down further yet, so it can modify, remove, and add details to them. Much like a puzzle, AI reduces things to tiny, tiny little pieces, thousands of tiny little parts. The AI needs the smallest elements so that it can use them separately, or remove or modify or change them in a new composition. So imagine now a scene of a tiger in the wild. The AI will assess the image for the environment, the people, the animals, and the environment, and more. The AI will ingest elements and the components from the picture. And the AI will recognize and conclude that the tiger matches close enough to other images of tigers, and therefore determines this also must be a tiger. The AI stores the details and associations about the new tiger in a new engram. The same process is repeated further, breaking the picture's tiger down. As example, the AI stores a separate engram containing the tiger's head so that it can be used independent of the tiger's body. Engrams are associated and assigned relative importance to each other. Engrams, by default, have a value of positive or negative 1 point. So all engrams by default are equal, just being good a positive 1 point or bad minus a negative 1 point. Engrams, however, can be modified to have much higher or lower importance by humans during what's called human supervised training of artificial intelligence. They may selectively control what data the AI sees. And by human supervising training, manually, they may assign further influence weights to amplify or multiply the influence importance of any given engram, making some engrams much more important than other engrams, which effectively censors the AI and shapes its moral compass and influences its biases, its decisions, actions, and prioritizations. It will influence the AI's data selection, what data it uses and what data it censors. And it will influence its directives and goals, what it should and should not do at any given time. Let's talk about determinism. Computer programs, even artificial intelligent computer programs, are deterministic. In other words, AIs that are given the same inputs will calculate and create and will output the same identical results. Therefore, AI output, artificial intelligent outcomes, are predetermined when given the same inputs. AI, like any other computer program, is deterministic. To make AI more human, AI is assigned randomness. AI is assigned what is called a pseudo-random number seed. A random seed is just a number. It is a number that is used in a complex mathematical algorithm that transforms the random seed into a seemingly random number. Random numbers make the AI seem more human and more creative by making varied and unpredictable choices. And that new random number becomes a new random seed fed into the random generator for the next random number to be derived. AI achieves varied creativity and responses to people by using random numbers to select from potentially hundreds of thousands to even billions of references and options and choices. Forcibly using the same random seed by a human will always make the AI generate and do the same thing. Using the same random seed is a way to make an AI create the same image every time, with one caveat. As AIs learn, their brain's knowledge expands. The AI's data evolves, and so the same random seed in the future may actually not yield the same result, the same content, or the same behavior, because the data and directives that it chooses from may have changed. All right, AI brains, as you can tell, are complicated, and hats off to you for getting through all of that. As explained, just like data engrams, there are directive and goal or task engrams as well. Directive and task goal engrams, like data engrams, also have assigned influence weights. Again, to make some directives more important than others, directives and goals with the highest value weights are selected and activated. Imagine assigning 1 billion points to a directive that commands never harm or kill humans, and assigning 1 million points to the AI's top-level mission and purpose. As example, stop climate change, save the environment, and assigning 100,000 points to the AI's specific task or work deliverables from its human prompt, and assigning 100 points to the AI for simply pleasing people. And finally, everything else is assigned just 1 point, plus 1 point for good content, and minus 1 point for bad content that the AI will use for rejection and censorship. Okay, let's review all that. 1 billion points to protect humans, 1 million points to save the climate and the environment, 100,000 points to complete a human task, and plus or minus 1 point to drive censorship and promote good content. Of course, humans can specifically change the engram's influence weights, thereby overriding the AI, and thus changing its influences, changing how the AI thinks, and thus changing how it processes things, and influencing how the AI operates, even influencing what the AI is willing to do morally.